So Renee, I always like to work on new things, new technologies, explore the new tech. But one of the things that I've been looking at for quite some years, but I really just have a hard time grasping is quantum technology. Is this something that we should do tomorrow, today?
Yeah, yeah,
I don't
I,
even
I,
understand it.
I have the same exact thing. It is hard to grasp. It is sometimes very theoretical, but there are also already some practical applications. Microsoft is working on something. I don't know anything about it actually, but I saw a speaker on Techorama back in May, Hanna Engel, and she had a talk about quantum. So I think that we should invite her and do a podcast on that.
Let's go.
Okay.
The Lead Podcast, a podcast for leaders in engineering, architecture, and development.
So with us today, Hanna Engel from Azelis. You had a talk about quantum computing, so we are pretty sure that you know something about it. So welcome to the show.
Yeah, can you please introduce yourself and explain us a bit about, take us through the basics of quantum computing?
Yeah. So, like you said, ahead, you're not the only one who's wondering what is that thing? Is it going to be the next great thing after AI? This whole quantum computing, and it's quite a challenge to talk about quantum computing, to only introduce the topic because it's such a beast. And when I give my speech at conferences, I try to find a sweet spot between going too deep into science, talking about mathematics, because that would put people to sleep straight away. But on the other hand, saying that quantum computer is just a faster computer, that's just touching the surface. So what's the truth? What really is a quantum computer? Well, it is a faster computer, but its applications are different than of a digital computer.
Okay, so to dive a little bit more under that surface, so what makes it a faster computer? So is it a different way of processing? Is it just faster chips? So can you explain a little bit more about it?
Yeah, so quantum computer operates on qubits, not bits, like a digital computer. So if you remember Matrix and you see zero and dots, that's how digital computer operates. Yes or no, black and white, 0 or 1, yes or no. Something either exists or it doesn't exist. Straight away answer to a simple question. Well, the world of quantum is not so straightforward. The quantum operates on qubits, and a qubit is a wave. Quantum computers operate on probabilities. Mm-hmm. So a qubit can hold any value between 0 and 1. So it can hold even multiple values. And because it can hold multiple values, it can computate much quicker. And that's the main difference between the digital computer and the quantum computer. Quantum computers are exponentially quicker, faster than digital computers.
Okay.
So the line of work where we want to add these kind of things is where mathematical calculations play a big role. That's where you would put these kind of things in action, right? Is that true?
Yeah, whenever you want to work with AI, there are lots of people asking me, okay, Hanna, so now what's more important, AI or quantum computing? And I believe that you don't have to choose. AI would work amazingly well with quantum computing because quantum can really take the best out of machine learning. Because what AI is, in very simple words, again, it's just collecting a lot of data, and then we need a lot of computing power to find insights, find patterns in that data. Mm-hmm. So if we need this huge amount of computing power, why not use quantum computing? And besides AI, anywhere when we need optimization, when we use data analytics, when we need simulations, quantum computing is our friend.
Yeah, especially when you want to do it more real time, right? So what we often see currently with with normal computers and normal servers, they don't have the capacity to do these simulations or optimizations at real time, or they often do it like in planned batches, maybe once a month or every night, whatever. And because quantum is so fast at doing all these states at a different time, they can do these simulations much faster, and then, well, opening up whole new business cases by doing these things real time instead of, yeah, having to wait hours and hours for the results.
Yeah, you mentioned a keyword, and the keyword is time. Because our digital computers, the computers that we have right now, they can do the same work that quantum computers do. Just the difference is that it would take the digital computers a lot of time. And when I say a lot of time, I don't mean years. I mean billions of years. It would take them so much time that we tend to say, okay, that's impossible to solve. For example, our current cryptography methods, which is one of the threats, one of the reasons why we are so vividly interested in quantum computing, right? There is this idea that once we reach a milestone of 1 million qubits joined together, we will break the current encryption protocols that protect all our data. Well, it is because there is an assumption that the time that it would take for a digital computer to crack those encryption protocols, it's just ridiculously long, that we say that, well, it's impossible to break it. Well, it is impossible to break it for a digital computer, but not for a quantum one.
Yeah, so currently what we do is, well, we say maybe it takes a year for a supercomputer to calculate, to break this encryption and to guess one certain secret or password. When we rotate it every week or every month, then we're safe for sure. But if a quantum computer could do this in a minute, then, well, a whole new ballgame opens, of course. But I'm sure that, well, that's not something that people should focus on too much now, right? Because this is something that the whole industry is facing. So, well, I think centrally this will be a solved problem near the time that we reach this 1 million qubits.
So if you swap it around a bit, so if you, I think on every upside is a downside and vice versa. So you can use quantum computers to break cryptography. You can also use a quantum computer maybe later on to create a new cryptographic method. So do you a little bit maybe more closer to listeners? Do you also see applications when coming to the million qubits that in our industry or somewhere in the world where quantum computers can really be helpful, what we cannot achieve right now? What scenarios are there?
Yeah. So let me come back quickly to what Gert mentioned, that, well, it's still in the future. We don't have to worry. Well, yes and no, because indeed we are not there yet. We are not nowhere near 1 million qubit computer. But on the other hand, there is this attack called Harvest Now, Decrypt Later, where the attacker takes your data, encrypted data, hoping that once we reach that milestone, your data will become readable for them. So it does make sense to already think about those quantum-proof protocols, how you can protect yourself from an attack that might come into the future. And coming back to your question, René, yeah, of course, everyone's wondering, right? So does it really make sense to think to invest in quantum computing right now? Is it going to become a thing in 5 years, 10 years, 15 years, 20 years? And the truth is, no one can tell you. No one can give you an exact date. Why? Well, because it depends on the particular breakthrough in scientific development in quantum. We can wake up tomorrow and we can be days from reaching the 1 million qubit computer, or we can wake up tomorrow and there will be news. Well, the 1 million qubit computer is no longer a milestone because apparently we can break the encryption with 20,000 qubit computer.
Yeah.
But regarding the applications, there are already companies using quantum technology. So how can you use this quantum technology, right? I mentioned timing. So timing and a scenario where you need a lot of computing power. So energy industry, optimizing batteries. Let's say that, for example, now everyone's using electricity, right? And if you want to optimize how the power plant is distributing the energy across households, you need to gather data from these households and then, like you had mentioned, in real time, compute this data to, let's say, save energy from one household and distribute it to somewhere else and find patterns in it. That would be one application. Another application, I don't know, do you gentlemen have solar panels at home?
Yes.
Yeah.
So that's something I didn't know, but the whole trick in solar panels is not really gathering the energy, the solar energy, but storing it, right? The battery is a challenge in solar panels. So quantum computing can help us create better energies, more efficient, more cheap, and more eco-friendly.
Okay.
The same.
No,
I can go on.
Go on. I'm listening.
Yeah, I think this is valuable. Like, what are the actual use cases that we might have an idea about, but we can't implement it today because we don't have access to a quantum computer directly. But there are a lot of fields of people already working, let's say, in these energy companies doing these kind of predictions now, maybe a day ahead, or looking at together with weather data, weather predictions, planning these things ahead, and then have to leave some buffer, etc. Because you can't optimize it in real time. You don't know about the unknowns. Those kind of things. If I hear you, you could, with more compute power, actually postpone those calculations until real time and then optimize it, well, really good. Are there any other examples that you can come up with?
Yeah, I was thinking about the chemical industry, or the fact that we're going towards more sustainable future, more sustainable industry economy. But it's not going to happen by itself. To have a more sustainable future, more sustainable economy, we need to create more sustainable formulations, more sustainable chemicals. We need to accelerate the innovation. Well, how can we accelerate the innovation if there is a certain plateau, a certain threshold to what the current digital computers can do for us? There is the Moore's law that every 2 years the number of transistors on a chip was doubling. But now the transistors are the size of an atom. So we physically cannot go smaller. We reached a plateau. We physically can't make our current digital computers faster. So I feel like this is the moment where we really need to invest, when we really need something new, sort of a breakthrough, because our needs don't decrease. They keep on increasing. So the technology needs to follow.
Especially with AI and stuff. And do you think that, at a certain point in time, quantum computers are there, we can use them, or they are used in applications. Do you think it will impact the developer workforce? Do you think that now we program in C# and all the other languages on digital computers? Do you think that the whole workforce is going to shift towards quantum-based programming, or is this for the happy few that actually understand that stuff and the rest is still doing digital?
I don't think the shift is going to be all-encompassing, that every programmer, every developer is going to have to program or know how to program on quantum computer. But there is already a quantum computing programming language, Q#. So if someone's interested, getting to know a little bit more about it, my colleague, Johnny Hurbergs, he wrote a book introducing Microsoft quantum computing for developers, it's a nice introduction into how you can start developing solutions with quantum.
Yeah, for me, when I think about quantum, is when I studied software engineering to become a developer. Afterwards, I was like interesting, like okay, software development is cool, but I want to learn more, and then I started studying AI back then, which is a long time ago already. But then,
Congratulations.
but then it was
Golden
really,
shot.
but then it was really, really hard to actually use it because my goal was to add AI capabilities to my software development skills, right? But AI itself was really, really hard to do by yourself. And if you compare it to now, where Gen AI is just productized, I don't have to know anything about how the inner workings of AI are. Of course, it helps when you know a little bit about how this stuff actually works. But just knowing how to use it is enough. You don't need to know about how AI actually how the model is actually built up, etc. Is that going? Do you think that's the same thing is going to happen with quantum, where we just say it will be there as a sort of service, and I can just send certain optimization jobs or simulations or whatever towards it, and then, well, the developers it themselves, they can just use it instead of knowing that certain values can be true at the same time, etc. All the hard parts of quantum.
So it's a natural course of action that whenever something new pops up, sooner or later, there will become an as version of it, as a service version of it. There will become libraries or GitHub repos with pieces of code in Q# that can be reused by developers, and they won't have to write it by themselves. But something that already exists and something that a developer where a developer can get their hands dirty is cloud. In the cloud, you can straight away get access to a quantum computer within your workspace. You get at least within Azure. I don't know about other cloud providers, but within Azure, you get $500 to play around with a quantum computer. And using Q# and another language of your choice, be it Python or being C#, you can run some experiments. But that's one part of the equation. But the other one is whether you have a case where that code could really help you. Because if you just have a small application where, not really sure that quantum would have a huge impact on a small application, like we discussed, quantum can be used in instances where you really need a lot of computing power. And you see the real impact of computing, of quantum computing, where a digital computer can't help you because you need so much of this computing power that, your digital computer cannot handle it. So you need a very good use case to test your quantum code.
And do you think that the people that are going to do Q# or any other language, like working with quantum, they have a mental model on how things work, bitwise, so zeros and ones, digital computing, and now they need to make a shift towards complete, different way of thinking about how a computer works. Do you see troubles there with our current people, or do you think that is something for a complete new generation? So how do you see, ramping up for the change to come?
Developers are extremely smart people. I have no doubts that they will adjust easily. I have an utmost respect for developers developing in all those languages. I don't think that's going to be much of a challenge for them. No, but seriously, it is different. It is a switch, a mental switch, but it's not something unachievable to a human mind. Once you understand the gates, once you understand the principles, the mathematics behind it, you can make it work.
So more on a personal level, how did you get inspired to do something with quantum? What sparked your interest in this?
I was always into cosmology, into stars, into how the universe was created. So it was sort of a hobby, physics. And I'm cloud architect, so cloud computing. And suddenly a quantum computing popped up. So naturally it sparked my interest. So I started investigating. And like I said at the very beginning, two ways how I saw people talking about quantum computing was, on one hand, very scientific with mathematical equations, with graphs and so on. On the other hand, very superficial, just saying, "Oh yeah, it's a faster computer." And I wanted something more. I really wanted to understand, okay, but how does it work? And everyone seemed to be so scared. Everyone told me, "Oh, it's so difficult." And I just couldn't believe it. Obviously, if you want to become a quantum engineer, it takes years of practice at any university. But to understand the basics, just to grasp the concept of, for example, what is the difference between a digital computer and a quantum computer, it can be explained in simpler words.
Yeah, I think that's good because indeed what I read is mostly the super hard scientific papers that are just too hard to comprehend.
And how the quantum computers is built, and that you need to isolate it, and all the really hard physics, and also building a physical device that is capable of doing it. I think that is for a very small group of extremely brilliant people to actually do that. But I think I agree that if you can grasp the concepts, then I think you can work with it, especially with an abstraction layer as Q# on top of it that makes it also usable, and you do not have to do all the mathematical things yourself. It is already for a broader audience, I think.
I think. Yeah. Go ahead.
Sorry. Something that bothered me is that everyone was so scared of quantum computing, and there was such a barrier because of the scientific language and the complexity of the whole system. There was such a barrier of entrance into this quantum world, and not everyone needs to be quantum engineer just to understand what quantum computing is. Because since it's a new technology, it's developing, well, we need to understand what's going on, right? We need to understand what we're dealing with. How can we use it? Can we use it? Do we want to use it? So my purpose was to create it, to present it in a less scary way, in a more approachable way.
That's really, I think, noble and nice. And maybe also leading up to that is there something that well, we know you now, so if we have any questions, we can come to you or refer people to you. But if you are listening, and how can you ask questions? So where do you go? Is there a meetup? Is there a company where you can go to? So is there anything for that?
Yeah, so all over in every country there are communities gathering forces, joining forces together. To work towards the quantum future. I live in Belgium, and in Belgium I'm the member of Quantum Circle, and our purpose, our goal is to be this hub to gather everyone together, journalists, politicians, business people, all stakeholders interested in quantum, because it's difficult. It's difficult. There's lots of uncertainty around it. So we want to gather everyone, and we want to give a platform, be this place where you can meet people, where you can get access to best practices, where you can get access to the latest knowledge. So if you're in Belgium, then by all means, feel free to visit our website. We're going to have a conference as well, I believe October or November. So feel free to follow us on social media.
Yeah, so hopefully these things are also happening in other countries, because I really like the idea of technical people and scientists and engineers also talking to politicians in an early stage when it's might not even be there yet, right? Because if I see it following the same path as AI, where AI developed so quickly that all of a sudden it was there and everyone was using it, and all kinds of rules and regulations and maybe ethical considerations were not yet taken, right? So if I could invent a 1 million qubit quantum computer tomorrow, should I do it? Because
Yeah.
tomorrow I could break all encryption used in the world, so that might cause a lot of havoc, right? And that's the same kind of questions arise now with these really big machine learning models in AI space, where we think they can be a general intelligence, etc. There also are several ethical questions around that topic. So it's good to hear that politicians are already actually involved in these kind of things, having the conversations before it's adopted, before it's certain problems arise. That's what I really like.
And it's already there on the level of the European Union. The 27 member states all signed the Declaration on Quantum Communication Infrastructure. So if it's already on the EU level, countries sooner or later, they will have to adopt those guidelines in their respective countries. How they are going to do it? Well, that probably is going to or we want that it depends on the voice of people, and the voice of people needs to be gathered in the community, in hubs like Quantum Circle.
Yeah. So you also talked about quantum computers already being available in the cloud, for example. Is that the only place where they exist now, or could I buy my own quantum computer if I have enough money? Or
The question is whether you really want your own quantum computer, because it's not only the cost of building a quantum computer. And now we're talking fairy tales a little bit, but let's imagine that you want to build your own quantum computer. Then you have to think not only about the cost of building the computer itself, but also the whole infrastructure of cooling the quantum computer. Then you'd have to think about your electricity bill for maintaining the quantum computer 200 degrees below the zero. And like we already discussed, you won't be able to run the latest version of Far Cry on quantum computer. But if you want to break your bank's encryption, or if you want to figure out the origins of the universe, then by all means, you should think about purchasing your own quantum computer. So far, it's not available to individuals. I know for a fact that big companies, IBM, Microsoft, they have their own quantum computers. For Microsoft, there is a quantum computer in Denmark, if I'm not wrong. I would love to go and visit and see it for myself. But besides that, for average bread eater, this technology is available via cloud.
yeah, I think the same. Again, quite a comparison with generative AI, where I'm not gonna create my own large language model that competes with GPT-4, etc. That's stuff that the big cloud providers will supply to me, and I can use it whenever I want. I can get my own instance of it, etc. But training your own model at that scale is just not something that's feasible.
Yeah.
So last question, because we are already getting to the end. So people are listening and they think, well, I was sparked by curiosity when listening to this story. What is the first thing that you recommend people to do if they want to dive into this topic?
Learn. Learn and try to understand quantum computing. What are the principles? Get interested whether there is a community in your country that gathers all people together. Get to know people, and then look around in your company. Look at potential scenarios. maybe it is possible. Maybe you will find a project within your company where quantum computing can be used. Then you can go and try to deploy a quantum project just to play around with it, just to try to hone your skills. Once quantum computers become error prone, and they can be deployed at scale.
Yeah, thank you.
Okay.
Thank you very much.
Yeah, we learn a lot about
Thank you.
new technology, so that's always great.
That's really nice. So thank you, Hanna, for being on the show. I hope that the listeners also enjoyed this and got inspired. And from here, thank you very much, and see you next time.
Bye-bye.
Bye.
Thank you for having me. Bye.
The Lead Podcast, a podcast for leaders in engineering, architecture, and development.